Yo, what's up guys? Recently, I took a coding challenge of spending 10 days on a project for BBC Microbit. I used the Microsoft Make Code editor to code and simulate the project. And here in this video, I am going to show you guys this amazing journey. Enjoy! In the first day, my goal was to come up with the idea for this project and start a few lines. After a few minutes of thinking and struggling, I decided to go with the idea of a mini-system that includes several functions. I started to program the loading screen of the system, which progressively fills the LED screen line by line. And then displays a simple happy face on the LED screen after that. I used the basic for loop and it worked pretty well. Then I added some randomness to the progress bar as well, using random generated values for the speed of the loading progress bar. And I also added some flashes between by clearing screen and adding pauses. After a bit of tweaking and adjusting the timing of things, I decided it was at least good for now. I added some comments to the project, since this is going to be a 10 days long challenge and I wanted to keep things organized. I also planned that I should work on this project for at least 15 minutes every day, and longer than that if needed. Move on to the next day, I started to program the home page of the system, where you can switch between functions and use the function you need. I created a couple variables for this feature and planned to choose an icon for each function. Since there are already a bunch of built-in icons for Microbit, I decided I will only choose from there. I went to the blocks editor so I can preview the icons easier, and that made things much quicker. After going through the gallery for several times and considering all the choices, I chose 7 icons for 7 different functions I thought was pretty good and reasonable. I put them into the order I wanted and the functions were a clock, a compass, a thermometer, a music player, a rock-paper-scissor game, the game Snake, and the function to quit and shut down the system. Some icons were harder to choose, like the icon for the clock, and I decided to use a small square for that. Then I switched back to JavaScript editor. Some codes were messed up because of the switching, but it was a simple fix and only costed less than a minute. I put all the icons into a list so I can program the home page by displaying the icon in the list indicated by the index of the function the user chose, which is stored in a simple variable. It was pretty easy. And after that I moved on to the switching logics. From what I planned, the user should be able to use the button A and button B to switch left and right, going through all the function and choose the one the user wants. I used the built-in functions to check the status of the 2 buttons and the switching was a simple logic and I only needed to apply operations to the variable indicating the index of the function that the user is on. And by the way, I also spent a minute or 2 to add a simple logic at the beginning so I can skip the loading, which was planned to save some time when I debugged the program. I definitely wasted some time on there since I tried to add a variable for it but removed it after I realized I overthought about it. I also wrote a long sentence of comment which I lately simply replaced with an equation stating the logic. This was not even necessary but I kept it anyway. I finished the code for the function switching feature, but somehow the program didn't work when I tested it. So I went on debugging and finally found out that I made a really obvious mistake that I surprisingly didn't even notice. I put the variables at the wrong place which made the program reset the index. All I needed to do was to move the initialization for the variables out the loop and to the place before the loop starts. But after I fixed that, the program still didn't work. Just as I worried before, the logic I used was taking the button pressing too many times. So I switched to the other way, where I simply added listeners to the buttons using the built-in functions. The 2 separated listeners was coded for each button. And then I moved the logics I previously wrote into the listeners. I also added the listener for the pressing of button A plus B at the same time, which I planned is to use the function. I kept it empty because I decided it was the job for another day. Day 3, I went back to the code and started to work on the first function, which I originally planned to be a clock. I wrote a custom function in the code, but soon I realized that Microbit didn't have a built-in clock, which means things is moving on to the harder way. I searched on Google and a tutorial from Microsoft Make Code had a clever solution, which is to make the user set up the current time and then timing from that time. It was some straightforward logic so I started to implement it right away. I started with the timing system, which used variables to store the current time and add a second to it every second. And also some simple logics for the minute and hour, which I used modulo operations and adding. I put all these logics in an interval loop of 1000 milliseconds, so it can be executed every second. And I affirm the code for this was basically done. So then I also add a line of code to display the time by simply combines the variables as a string. I didn't know if it would work or not, so I started to write the code to start the function, in order to actually test it. I used a switch statement to execute the function based on the function number variable I previously wrote to store the index of the function that the user chose. If the function the user chose was not yet implemented, the system will just simply display a sad face. And just to keep things organized, I added more comments about each function, so I knew what I was doing. While I was doing that, I got disrupted, and when I realized that the quitting the system part was pretty easy to do. I started to work on it but got a new idea of add another function to reset the system. I don't know why anyone needs it, but since it is easy to do, I just decided to add it anyway. Since there is already a built-in way to reset the system, I finished that function with just a few lines. And for the function to quit, I added a new variable that I could use for the while loop. I only need to change the variable to false to end the loop, which will bring the program to end. I finally went back to test the timing system for the clock, but it didn't work somehow. The time stays at 0. The reset function worked and the quit function was a bit glitchy, but I didn't dig in. I was facing the problem of the timing system, that I didn't know what went wrong. I checked over the logics in my head, but it all seemed correct. I didn't know what to do, which made myself a bit frustrated. I decided to debug the program, but just after a quick debugging, I soon spot the error that I put the interval loop in the wrong place, which made the loop never be able to start. So instead of putting the interval loop after the while loop, I moved it to the far beginning of the code. After that, the timing basically worked. Then I started to add some formatting to the time, that the numbers will be forced into 2 digits long. I put the formatting into a small function that I could reuse, so it made it easier to format the both hour, minute, and seconds. The formatting code had a bug which I didn't notice at that time, but it will be revealed later on in this video. Besides that, I also should add the way for user to set or adjust the current time so it could work as an actual clock. But I went lazy and just decided to rename this whole function to a timer instead. I basically renamed every related variable and function, so it officially became a timer with no doubt. The function was still glitching and the home page was still showing the function icon even when the function was running. It was awful, but since I had already worked a lot on that day, I decided to call it a day and left these bugs to another day. So the next day, I brought up this solution of having a variable to store the running function number. If no function is running, such as if the user is on the home page, the variable will be set to -1. I only needed to check that variable and either use a function or display the home page based on if the variable is less than 0. Thus the home page and the functions themselves will not interrupt each other when one of them is running. I also cleaned up the code and rewrote the control system for running different functions. Basically, in the button listener, I set the variable to the number of function that the user chose, and used another switch statement to execute the function after the if condition to check if the user should be on the home page or in a function. And after double checking and adding comments explaining things, I took the first test of this piece of new code. Now this time, the home page glitch didn't appear, which was a success. But the time showing in the timer function stayed perfectly still. I quickly solved a few obvious bugs that went wrong because of the change of the control system, such as removing the while loop in the function, since the control system will now running the function over and over again, so there is no need for having a loop inside the function itself. And the initialization of the time should be put outside of the function so that the time will not be resetted every time. The timing was running after the fix, but still it was horribly wrong. And that's when I found out the error I made when I wrote the formatting function. It was a very simple solve. I just messed up the order of things. So that when a number is 8, the previous code changed it to 80 instead of 08. I went on testing and the code started working. After making sure the code was correct, I made the decision of removing the hour segment on the timer, since it most likely would not be used and would only make the time longer and harder to read. I also removed the formatting on the minute, so it can be expandable and be how many digits it wants to be without any limit. I simulate the program and it went through the test successfully, so I decided to move on to the other things. There were still a lot functions that needed to work on, but I skipped the compass function and started to work on the thermometer, since I thought it would be easier. I created a new function in code for this thermometer function, just as I did with the timer. Again, I cleaned up some code and removed some comments that I thought was not necessary. The code for this thermometer was indeed pretty easy. The microbit has a built-in sensor to check the temperature, so all I needed to do was to display this data out, and the plot bar graph function was built perfectly for this. This immediately worked, as the bar graph is live updating and can display the temperature in real time. And I also add a tiny bit of math so that it also worked with negative temperatures in the limit of -5 to +50. However, one problem with this function is that somehow, the function cannot be quitted. As I programmed, the function should be able to quit when user press the button A+B. It all worked on the timer, but not on the thermometer this time. It was all so strange, that I could not even figure out a clue of why this happened. I kept on debugging for a while and read over the code, still I could not solve it and it stayed as still, like as a glitch coming from nowhere. I tried a lot and all my attempts failed. It seemed like the listener just stopped working after the thermometer function started, it just could not respond to the button pressing events. I didn't know what else to do, so I took the rest and hoped I could get some ideas on the next day. So now it's day 5, halfway through the challenge. I still didn't quite get the reason why the program wasn't working. I was messing around with the code, and that's when I got an idea. Basically, the idea was to simply add another checking for the button A+B pressing inside each function. So I quickly wrote this piece of code and made it into a little function so I can reuse it in every function. Now it is working, as every time the user presses the button A and B at the same time when a function is running, the function will be ended and the program will reset to the home page. After multiple tests, I was pretty sure that the program was doing good. I was not sure why the previous code didn't work and why this new code worked, but as long as it works, I don't think there is a reason to bother it, so I kept it. And I added some comments to the project as usual, and it was pretty much the time to move on, as I still got a lot things to do. One of the other things I needed to work on was to solve the glitch that happened after the user chose to quit the system. Basically, the function was not fully finished and I needed to add a few things. I first made sure that the screen is going to be cleared when the user quits. And also I needed to add a few condition statements to disable some functions like switching in the home page once the system is supposed to be shut it down. After these changes the glitch was gone, and it could be cleared off from the checklist. With no bugs or glitches needed to be solved, it was time to continue implementing more features. And this time, I chose to work on the compass function and planned to hopefully finish it before I would call it an end of the day. It was just some basic setups, basically exactly the same to what I did with the previous timer function and the thermometer function, just a new custom function and adding a bit to the switch statements. I used microbits built in Compass to get the heading degree. With a tiny little bit of math, I can convert this degree number to a single-digit number from 0 to 7, since 8 is the number of the arrows I can use to display the direction, and 0 to 7 is exactly 8 numbers that I could use. After a bit of testing and some slight tweakings, I was able to get the board to correctly show the number based on the direction the north is. Now the first half of this function was done. The second half was just to display an arrow based on the number I got. I started off with a simple switch statement to show the correct arrow in each case of the number. It was almost like some replicated works, and in each case the arrow was the only thing that needed to be changed. I needed to make 8 cases and each with the arrow assigned, and you can say it was some boring works. So after a lot of copying and pasting and editing, I finished the code for all 8 cases in the switch statement. After some quick testing, it worked perfectly fine. Just as you can see in the video, as the compass for the simulator changes, the arrow on the LED screen also changes along based on that. Then I simplified the program by putting all the arrows into a list that would be listed based on the number each was assigned with. After that the logic became pretty simple. I just needed to get the arrow on the index of the number I calculated, and that arrow will be exactly the arrow I needed. It was another long boring work of rearrange all the arrows into the list, but I thought it was worth it, since it now definitely looks way cooler with no doubt. Then I started to add more comments, improve existing comments, and rearrange some pieces of code to make the whole program looks better. I did several small changes and simplifying to some parts of the code to make it more clean. It was just some usual things that I think I probably already did several times throughout this video. After spending some minutes on that, I was pretty satisfied about the result, and also happy about achieving the plan I made earlier on, about finishing the compass function right on that day. And with that good mood, it was again the time to move on to another day. Day 6, already past the halfway point, still 4 more days to go after this day. Since there were a lot of repetitions going on in the switch statement, I tried to make it more simple. Now there are some cases that are sharing the same logic. After making sure I didn't accidentally break the program, I was up to implement yet another function. The next function on my list was the music player, which I thought was pretty easy. With all these amazing built-in features in Microbit for making music and sounds, it would be pretty easy to make a program that can kind of play a song with notes. And due to some previous projects, I had some lists of frequencies that can make up songs. I chose the classic birthday song. And by using a simple for loop and the to list for each the frequency and the duration, I thought the program would play the notes pretty well and make it sounds like happy birthday to you. However, little did I know that what was waiting for me. The code cannot be compiled and it showed absolutely no errors in the editor. It was a huge and terrible fail, and I had totally zero ideas of why it happened. I tried refreshing the page several times but it made no changes. I even tried to reboot my computer but unfortunately I still didn't get the reason of all these happening. After messing around with the code for a while, I got no hope at that time and didn't know what to do, so I just wished that the problem could get solved in the next day and quitted the editor. I started off day 7 with an idea. I made another project and copied the same code into there. Unfortunately it still didn't work. But what I noticed is that when I tried to put the piece of code for playing music into a new separate project, it worked with no problem. And almost immediately I realized the problem, and that's how I named the function in the code. I regretted it so hard and didn't know how I didn't think about it earlier on. Basically I put music as the name of the function, which apparently is also the name of the namespace for Microbit's music functions. And that's what made the code failed to be compiled. Now these all are solved, I got to work on something else. I picked something very easy that day and it was the rock paper scissors game. All I need was to generate a random number in the range of 3, and that can represent whether the microbit is going with rock, or paper, or scissors. I also added a countdown and some delays so the user can play with the microbit board. It also keeps going and going until the user quits. I did some testing and made sure that the program was doing correct and the rock, the paper, and the scissors both have a chance to show up. After I was sure it was all good to go, I added a few final touches to that piece of code. Other than that, I also did some optimizing jobs on the other pieces of code in the program. It went pretty smooth and I decided it could be the end of the day, and I knew that the next day I was going to start something more cool. And yep, that's of course the snake game. With some very quick and simple setup, I got this custom function to work with. And I knew this single function would be the hardest to make among all those different functions in this mini system. I got to use this 5x5 LED screen on the microbit to display the snake and the apple, which I already had some ideas about how to attempt it. With all those in my head, I went on to create the variables I planned that I would necessarily use for the logics. And I also coded a while loop to run and render every frame of the game, until it's game over. For the game logics, I first started with the logic for the apple, and that was pretty easy. I only needed a condition to check the position of the head of the snake and the position of the apple, and if the positions are the same, the apple will be eaten and the snake will grow one more body part, then the apple will also move to a new random generated position. I had this variable called direction, to store the direction the snake is currently facing. And I used this variable to make sure the new generated body part is going to be at the right place. I decided to store the direction as a number, so there would be 4 possible numbers for this. Based on my plan, 1 was going to be up, 2 be right, 3 be down, and 4 be left. After adding a few more comments, I kept working on the body generating part and soon finished it. Basically I just needed to get the position of the last part of the body in the array I created for this, and shift that position based on the direction the snake is currently facing. So like when the snake is going left, the new body part will generate at the right of the last part. It pretty was straightforward, and along the way I also finished the code for moving the head in just a few minutes. The next was to move the body parts accordingly, and that was not too hard. I just needed to use a for loop from the end of the array to set each part to the position of the part prior to it. I started to test the program just to see if the code I got so far was working, but it wasn't and the program eventually crashed. After all, it turned out I made a mistake on the moving head part. I soon fixed it, and it should be able to work. To make sure everything was correct, I quickly wrote the code to render the things on the LED screen. I used the positions in the variables and plotted the LED based on that. I also made the LED for the apple a bit darker than the LED for the snake, so the user can actually tell which is the snake and where the apple is. This rendering logic was being put in the while loop just as the rest of the logics for this game, and they will be executed over and over until game over. After adding a few small changes in a short time of testing, I started to add the logics to verify if the snake has died, or in the other words, if it is game over yet. Basically I needed to check 2 things, one was if the snake hits the boundaries, and the second was if the snake hits itself. The first one was easy, Just needed to add a combination of 4 comparisons between the position of the head of the snake and the boundary limit on both axes. The second needed more work, but the basic idea was to check the position of each body part and check if any was in collision with the head. I thought it was pretty much all the work other than the logics for the controlling, so I added a simple flash to the game over for the enhancing of course, added a bit comments for the clarifying, and tested it. It crashed right away somehow, but the second time and after that went pretty good. I knew there was probably a mistake in my code, but I didn't bother it right away. It still obviously had a few bugs and glitches, but the main part of all these logics was done, and I had some vague ideas about fixing these and implementing the rest. Thus I called it a day, and I think we only have 2 days left now. Move on. In this day, I started with continuing on making the snake game. I first needed to fix the bugs, and that was exactly what I did. There were occasions that the program would simply crash midway in the function. I went on debugging the program for a while. I used the editor's debug tool to go over each line of code as the program is running, and check the result of some calculations and logics to make sure they were correct. I had a bit tough time, but luckily I finished it not too long after. So then I started to add the controlling system for the user to play the game, which is to move the snake around, since this was what the game was all about. I moved the variables to the outside the custom function for this game, so they are now global variables, and I can access and modify them in all other places in the program and inside other custom functions. I added pieces of code inside the button A and button B pressing event listeners, and the code was planned to check if the user is playing the snake game, and if yes, then the code will update the snake direction if the button A or the button B is pressed. Because the direction was stored as a number from 1 to 4, it was pretty easy to update the direction. I just needed to add the direction variable by 1 or subtract it by 1, and also make sure that the variable stays inside the bound of 1 to 4, otherwise the game logics will be broken. Soon after I fixed a small issue about the initialization of the game in each round, I started to test the program and see if the game is working. But it didn't turn out perfectly correct. Button A to turn left was pretty much working, except when the user pressed it the snake actually turned right instead. And the button B, which is to turn right, was malfunctioning and didn't work at all. It turned out that I messed up the math operations to update the direction variable, and after the easy fixing, the game was pretty much working. Now the snake game was probably completely finished, and I guess there was not much works left for this mini system. And these works was for the next day, which is also the final day. Day 10. We are coming pretty close to the end. I brought up with the idea of being able to restart the system after the user shut it down. I used the touchable logo on the microbit for this feature, and please be aware that this is only available on microbit v2. I could use the event listener for the long pressing of the logo, and simply reset the program with the built-in function, which also restarts the system. Other than that, I went over the program for several times to try to find code to optimize and bugs to fix. Soon after, I decided this whole project was done. So as you went along, this mini multiple functional system for BBC Microbit, this 10 days long project, costed about 4 hours of planning and working and included more than 300 lines of code, was announced as finished. And this awesome and amazing journey was ended. If you want to have the access to the source code of this project, for whatever purposes like studying, you can find it on our website linked down below in the description, available for purchasing. And without any further ado, let's take a look and enjoy the final result.